In this section, we're going to look at fractions, decimals, and the order of operations. And when I talk about fractions and decimals, we're going to look at the connection between the two. So let's look at a couple of definitions. So first, we already know that a fraction is a way to represent part of a whole, okay, or division of quantities. A decimal is a way to represent fractions and numbers that are not whole, okay? So essentially, both fractions and decimals are ways to represent part of a whole. And because of that connection, all right, because fractions and decimals are just different ways to represent part of a whole, we can convert between these two types of numbers, okay? We already talked a little bit about writing decimals as fractions. We did that way back at the beginning of this chapter, okay? So you would make note of the place value of the last digit. Okay, you would put the decimal over the power of 10 that represented that place value, and then you would just simplify. Okay, what we're going to look at for topic one is writing fractions as decimals. So first of all fractions have a decimal equivalent. So every fraction out there, we could write it as a decimal, okay? It's either going to be a decimal that terminates, meaning the decimal just ends, or it's going to be a decimal that repeats. So it either repeats a single number or it repeats a sequence of numbers, okay? Now, when it comes to decimals being written as fractions, not all decimals have a fraction equivalent. So I mentioned this very briefly in a previous video, but we have rational numbers and then we have irrational numbers. Okay. Rational numbers can be written as fractions. And because rational numbers can be written as fractions, they are also going to have decimal equivalents. So remember, every fraction has a decimal equivalent. So these end up being decimals that terminate or repeat. And you can see I have that typed out. So a decimal that ends is called a terminating decimal. So a decimal that just ends, the numbers stop. That's a terminating decimal. So 1.75, 1.639, those are terminating decimals. The number just ends, okay? Now, a decimal that has a repeating pattern of numbers is called a repeating decimal. So you do have to be careful here. Repeating decimals can repeat a single number or it could repeat a sequence of numbers, okay? So be mindful of that. And to kind of find a shorthand way of writing repeating decimals, we use something called an overbar. Okay, so we put an overbar over the portion of decimals that repeat. So consider like 0.33333. That 3 repeats forever. We don't really want to write that. That's like kind of a weird way of writing it. Instead, we would take the smallest portion that repeats, which is just the 3, and then we put a little line over it. That line is called an overbar. So these two things are equal. They say the exact same thing. One's just a little bit slicker. It's a little cleaner. It's a little more crisp than the other. That's all. Okay. So those are your rational numbers. Those are the decimals that terminate or repeat. Now, irrational numbers cannot be written as fractions. And we already know fractions have decimal equivalents, but what about these numbers that can't be written as fractions? Well, they're certainly decimals, but they don't have a fraction equivalent, okay? So these are decimals that never terminate or repeat. Okay, so if they never terminate, they never repeat, it's just a decimal that goes on and on and on and on. That would be an irrational number. So examples would be things like pi. We've talked about pi, that's an irrational number. Non-perfect square, so something like the square root of 2 or the square root of 10, those are also irrational numbers. Okay, so let's go ahead and look at example 1. So example 1, we're just going to list out examples of different types of decimals. So for part A, it says list a terminating decimal. You could list any decimal that just ends. So something like 0.873. It just ends. We could say something like 0.25, 0.625. Those are all terminating decimals. They just end. Okay. Now, the next one says list a decimal that repeats a single number or just one number. So we could have something like 0.111. 1 dot 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 dot. So that 1 just repeats forever. But remember, we wouldn't write it like this. Instead, we would take the smallest portion that repeats, which is just the number 1, and I would put a little bar over it, which is called an overbar. So that tells me that 1 repeats forever. Okay? Now you can hear my dog. She's going to start barking. So it says for part C, list a decimal that repeats a pattern. I don't really want to say repeats a pattern. I like to think of it more as a sequence of numbers. So it repeats a sequence of numbers. So I could have something like 0.12, 1, 2, 1, 2. Okay. Well, instead of writing it 1, 2, 1, 2, 1, 2 with a dot, 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 we would say, okay, what's the smallest portion that repeats? Well, I can see that it's a 1, 2 that's repeating. Okay. So I would write this as 0.12 with a bar over the 1 and the 2. That indicates 0.12 and the 1, 2 keeps repeating. Okay. Now for part two, or not part two, but example two rather, we're going to look at steps to convert fractions to decimals. So we already know kind of how to take a decimal and write it as a fraction. That's no big deal. We did that in a previous section. But for converting fractions to decimals, we need to understand the steps. So the first thing we do is we take the numerator and we divide it by the denominator. So if we have a numerator, that's the top number, over denominator, bottom number. If I wanted to convert it to a decimal, I would take the numerator and divide it by the denominator. But we're probably going to use long division. As much as we like to think we don't love long division, it's really powerful, it's really useful, so we're going to use long division. Okay, so you take the numerator and divide it by the denominator. Continue dividing until there is a 0 remainder. Once you have a 0 remainder, you have your decimal, and that would indicate a decimal that terminates, okay? Now, if you don't get a remainder of 0, you want to look for a repeating decimal, okay? If you do not get a 0 remainder or a repeating decimal, get an estimate by rounding to a particular place value. So sometimes the remainder of 0 or the repetition isn't going to happen for a while. It's going to take many, many decimal places for that to show up. So in situations like that, it would be absolutely appropriate to just round it to like the nearest hundredth or the nearest thousandth or something like that. Okay, so let's go ahead and look at examples of this. So for example 2, it says write each fraction as a decimal. Okay, so for part A, we have 9/40ths. Okay, well, I want to take 9. Let me actually give myself a little bit more room. I want to take 9 and divide it by 40. Well, hopefully you're like, well, how? 40 is bigger than 9. And you're absolutely right, it is. So what we do is we add a decimal and a 0. I know 9 is exactly the same thing as 9.0 or 9.00 or 9.000, okay? So you can add a decimal and a 0. It doesn't change the value of 9, but it gives us a way to divide. So I want to make sure to pull my decimal up into my answer, and then I just pretend that 9 is 90. So will 40 go into 90? And the answer to that is yes. 40 will go into 90 2 times. Well, 2 times 40 is 80, so I want to subtract 80. That gives me 10. Go ahead and add another 0 and drop it down. Okay. Well, 40 will go into 100 2 times. 2 times 40 is 80. This time we get a 20. Go ahead and add another 0 and drop it down. And now we have to figure out how many times will 40 go into 200. So let's think about this. I know 4 will go into 20 5 times. So let's see what we get if we do 40 times 5. Well, 40 times 5, 5 times 0 is 0. 5 times 4 is 20. So 40 actually goes into 200 exactly 5 times. So I put the 5 up here. 5 times 40 is 200. I've got my 0 remainder. So I would say 9/40ths is exactly equal to 0.225, or we could say 225 thousandths. Okay? So it's, I think, fairly straightforward. It takes a little bit of work. You've got to do long division, which students don't tend to love, but let's start to appreciate it, okay? Now for part B, we have -5/6. So I want you to understand that if your fraction is negative, your decimal equivalent is also negative, okay? So I'm going to go ahead and put equals and then throw in a negative right off the bat so I don't forget it, okay? Now off to the side, I need to take the numerator of 5 and divide it by my denominator of 6. Well, 6 won't go into 5, but I can add a decimal and a 0. And as long as I pull my decimal up into my answer, I can pretend that 5 is a 50. Okay? And 6 will definitely go into 50. In fact, 6 times 8 is 48. So 6 will go into 58 whole times. Now, 8 times 6 is 48. So we want to subtract. When I take, make sure you do 48. So 50 minus 48 is 2. Let's go ahead and add another decimal, drop it down. So now I want to figure out how many times 6 will go into 20. Well, 6 will go into 20 3 times. 3 times 6 is 18. So 18 minus, or 20 minus 18 is 2. So add a 0 and drop it down, and we've got another 20. So we're kind of like, we got a 20 again. Let's do this at least one more time. So 6 will go into 20 3 times. 3 times 6 is 18, and I got a 2 again. Well, if I add a 0 and drop it down, I've got a 20 again. And I know that 6 will go into 20 3 times. I'll get 6 times 3 is 18, and I'll get another 2 remainder, which turns into a 20. I could keep doing this till the end of the semester, and I'll keep getting a 3. So at this point in time, we can say without a shadow of a doubt, that 3 is going to keep repeating. So when I come over here, I would say, okay, negative 5, 6 is equal to negative 0.83. We're going to take the smallest piece that repeats, which is the 3, and we're going to put a bar over just the 3. Make sure you don't put the 8 under the bar, because if you put 0.83 with a bar over the 8 and the 3, that is completely different. Just the 3 gets the over bar here. So there you have it. Okay. Now let's look at 2/9. So for part C, we have 2/9. Okay. So I want to take 2 and divide it by 9. And hopefully you're starting to understand that, hey, 9 isn't going to go into 2, and that's okay. We add a decimal and a 0, bring the decimal up into the quotient, and then we can pretend 2 is 20. Okay? So 9 will definitely go into 20. It's going to go in twice. So 2 times 9 is 18. Well, 20 minus 18 is 2. Okay, well, 9 into 18 is still going to go in twice. 2 times 18, or 2 times 9 is still 18. So I get another 2. Well, 9 is still going to go into 20 twice, because 9 times 2 is still 18. I got that darn 0 remainder again, so I could keep doing this all day long. Okay, the 2 is going to keep repeating. I'm going to keep getting a remainder of 2, which turns into a 20. It's just going to keep happening. So I would come over here and I'd say, okay, 2/9 is going to be 0.2. The single 2 is the smallest part that repeats, and I'm going to give it an over bar. Okay. Now for part D, we have a mixed number, which is fine. So we have 2 and 2/13, and we're told to round to the nearest thousandths place. Okay. So first of all, my final answer, this whole number is just going to be the number in front of my decimal point. So I don't have to include it in my actual calculation. I just bring it down. So my final answer is going to be 2 point something. Okay. And then I just want to divide out my 2/13. So 2 divided by 13. Well, I'm going to add a decimal and a 0, and I'm going to pretend 2 is 20. 13 will go into 20 one time. 1 times 13 is 13. When I subtract, let's see, 20 minus 13 is 7. So let's see, 13 into 7. So 13 times 5, I think, is 65. So let's just double check over here. So 13 times 5. 5 times 3 is 15, carry a 1. 5 times 1 plus 1 is 6. So I can say that 13 will definitely go into 75 times. 5 times 13 is 65. So I get 5 left over. Let's drop down another 0. So let's see, 3 times 3 is 39. Let's see, what is 30 or 13 times? Let's look at 13 times 4. Let's see if that will go into 50. So let's see, 4 times 3 is 12. So I keep a 2, I carry a 1. 4 times 1 plus 1 is 5. So 13 won't go into 54 times, so we just have to say 3. Well, 3 times 13 is 39. So I get 11 left over. And let's stop for just a moment and think about this. The directions say, hey, round to the nearest thousandths place. Well, this is the thousandths place, but I don't know at this point if I round up or if I round down. So I need to divide one more full cycle so I know if I round up or down. Okay, so let's do this one more time. So let's add a 0 and drop it down. And now we're looking to see how many times 13 will go into 110. So let's kind of think about it. So we know 13 times 4 is 52. So it won't go in, well, it might go in 8 times. So let's see. Let's do 13 times 8. So 8 times 3 is 24. So I'm going to keep a 4, carry a 2. 8 times 1 is 8 plus 2 is 10. So that actually works. 13 will go into 110 8 times. I subtract the 104 and I get 6, but I can stop at this point. I just needed to divide out far enough to know if I need to round up or if I need to round down. Well, what I have now is 2.1538, but we're going to round to the thousandths place, which is this 3. To the right of that, I have an 8, which tells me to round up. So I would say finally, my final answer is approximately 2.154. And that is 2 and 2/13 rounded to the nearest thousandths place. Okay, so that's how you convert fractions to decimals. All right, there we go.